This is Dr. Ronald Muhumuza, working with colleagues at Ulster University, and have been carrying out extensive tests on our SwanaSmartStore prototype at our laboratories. What I'm going to share with you here are the field trials that have been conducted on a similar prototype in Botswana, and also the impacts that we actually foresee for Zimbabwe and the rest of places that require this kind of technology. So what we conducted was a field trial in Jamataka village in Botswana, which is an off-grid location. And over there, we installed a single PV module, single solar catcher prototype, which is similar to what Adrian showed you earlier under the solar simulator. And the system was designed to produce 0.8 kilowatt hour per day of electricity and 25 liters per day of hot water. So in the teacher's house, as you can see in the photographs there, we were able to support lighting load, television, fans, and a phone charger. And the solar catcher was able to provide hot water for bathroom washing and taps. So this was all from a system that was installed facing north at a 20-degree slope angle of the roof. So again, as you see there, our technology is actually a scale, is capable of being scaled up to meet various needs, ranging from households to institutions. So this is the case where we installed again in Jamataka village at a school to support various loads in the school building. So what you see there is two systems interconnected, facing east-west facing, again at a 20-degree angle. And in this case, we scaled up to a system that could provide 1.6 kilowatt hour per day of electricity and 50 liter per day of hot water for carrying out, providing preheated water for cooking in the school kitchen. And as you can see on the extreme right there on your screen, photocopying services were being provided to the school by our system, which was actually supplying electricity through an inverter. So those are kind of benefits that we can see at an institutional level from our SwanaSmartStore technology. So as you can see, the system is able to provide energy and it's scalable to a wide range of consumers ranging from low income to high income. And some of the impacts really, as we have been seeing from our previous speakers, the critical element is energy access, provide electricity for hot water. Those are some of the benefits we are targeting, both in the rural and urban context. So although the previous project did not incorporate the grid connection, in this SwanaSmartStore, we have brought in intelligent technologies that can integrate the grid and provide some autonomy. In addition to that, we have, in cases where the grid is highly intermittent, for instance, in Zimbabwe, we have a lot of, quite a substantial amount of hours of grid outages. SwanaSmartStore has potential to provide energy security from that context in terms of improving the power quality. And then where we bring in our intelligent control technologies, we are able to see when the grid is under stress so that we can actually deploy energy from the SwanaSmartStore. So an element of demand side management to improve grid stability during peak times. And associated to all these are the wider impacts that can be derived from all this. When communities access education and business opportunities, we bring them out of the poverty trap, and also offsetting unclean energy sources, over-reliance on wood fuels and diesel fuels, which avoids environmental pollution and improves and addresses climate change. So with all those impacts, we see health improvement and also, in general, crime reduction. And most of these impacts definitely are going to be addressed and demonstrated in our next studies on our socio-economic impacts to demonstrate what our SwanaSmartStore technology is capable to deliver.